Okay, this video is an example, another example of the PERT network and how to manipulate the terms and complete the process that we need to complete. This will be helpful, hopefully helpful on your completing your quiz as well. So again, this is a review of tasks that you need to do. Again, information that's given in terms of optimistic, most likely, and pessimistic completion times. Then you'll calculate the mean completion time, the variance of the completion time for each task or activity. Then using the critical path method, determine the project's overall completion time and its critical path. Using that information computed, and then next calculate the variance for the project's completion time, and then using the normal distribution, calculate the probability of completing the project within a specific time. So I'm going to go through an example fairly quickly. It's problem 9.28 on page 406 of your textbook. It is the Center for Information Technology at State University problem. They're moving offices, and they have 10 tasks from packing offices all the way through faculty setup of computers. So 10 tasks that need to be completed. This is the base information. I really encourage you to work through this problem and don't just assume that you can do it. The problem requires you to build the network, which this is the solution for, and also to calculate the data that's shown in the table there. Of course, you would need to calculate the means and the variances. These have been rounded to, the means have been rounded to 1 decimal place, the variance to 2 decimal places in order to complete that. You'll need to find the overall project mean completion and the project variance. So that's what you need to do, and so I'd encourage you to do that. One thing I want to point about this network is that you'll notice that in the textbook, neither task A nor B nor C have predecessors listed. And I would encourage you to note that the way that that's handled is to add, if you will, it's what's called a dummy node or a dummy activity here that we're going to call the start activity. Its duration is 0, but it does serve as the predecessor for A, B, and C. And because 0, as you start your calculations, because 0 is the earliest finish time of this dummy activity, 0 will be the earliest start times for A, B, and then of course C. So that's just a device to use to tie everything together. Similarly, that could happen on the end, where if not everything is tied together, and this all comes together nicely and ends at task J. If that were not the case, if, for example, H, I, and J were not tied together, you should add a dummy finish node out here. I'm just going to call it finish, and it also has a duration of 0 that will tie everything together. And then using the rules for the early start, early finish, and late start, that would tie everything together. So hopefully that's logical. Hopefully that makes sense, and it's a good device to use. All right, so moving forward, this is the solution when completed, and you'll notice I've taken the mean, and for all of these means, I've just put them into the into their respective durations for A, and A, the duration is 3.0. For C, it's 4.2, and so forth. and then have done the calculations through the network, early start, early finish, and through the network, and then backwards through the network, late finish, late starts, determine the critical path. And of course, our critical path is from our starting point to A, to D, to E, to G, I, and J. Okay. And then from there, you'll want to, the project's mean completion time is 23 days. And you'll calculate the variance of the project by adding up those activities on the critical path. So the variances of the activities of the critical path. So that's 0.44 for A. These are A through J. A, B, C, D, 0.25, E, 1, G, FG, 0.69, G, H, I, 2.25, and 0.25. So those are the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 tasks on the critical path. Once you add those up and take the square root, you'll get the standard deviation. So then we'll show that on the next slide. All right, the next slide has, our average, as we said, was 23. The standard deviation, 1, 2, 3, 4, 5, 6 is one, square root of that is 1.7. We find the z-value, which is negative 1.18. And then using our rules to go into the table, we know now that the probability of completing within 21 days is 11.9%. And we'll use the table for that. Remember, 1.18 is the z-value, or negative 1.18, and negative 1.18 is, positive 1.18 is 0.8810. And so to find everything that's above that, we'll subtract that from 1. And so 1 minus 0.8810 is, of course, 0.1190, or 11.9% chance of completing 21 weeks. Okay. All right, and so then the next slide is just another explanation of that, more detailed explanation. Again, what you'll recall is we want the area under the curve that we want to find is this area to the left of 21, that small area. And of course, we know that's the same as this area above, even though my pen is not accurate. That's the same as the area above positive 1.18. And so to calculate the area above positive 1.18, you subtract everything to the left from 1, and that gives you this value. And that's this value here. Everything to the left of positive 1.18, so taken from 1, is this value. Okay. And so the next question, logical question, is suppose that the management wants a 75% chance that the project will be completed within 21 days. Well, again, in order for that to happen, the average project completion time has to be less than 21. And so this probability that's under the curve has to be 75%. And so in order to do that, we know from the previous example that Z is value that corresponds to 75% is 0.68, and we'll use that information to allow us to solve for the mean. And by following through, you learn that the mean is 19.8 days. And so in order to achieve 19.8 days, you're going to have to crash the network. Okay. And again, the last slide is just the table, and the value, the lookup value for the table was 75%. And again, this was the same as the previous example. In this case, we wanted to be at least 75%, so we chose 0.68 rather than 0.67, because that 7.7517 is larger than 75%. So hopefully that's a quick explanation. Again, work through this example. Let me know if you have questions.